one has a base 3. So I'm going to start off, and I know you don't have a whole lot of space. You'll just have to squeeze it in, make them super small. Make your table for y equals 3 to the x. So that's your y equals 3 to the x table. What do I have to do with that table to create my log table? Flip it. All right, so that's our table. So now that we have that situated, we're ready to answer the questions about our transformations. So A is 1 because that's the number in front of log. H is inside the parentheses and you have to flip the sign. So what would H be? Positive 2, which means it's going to go right 2. Now remember, for a log, H is the MVP. This value here is also going to answer our domain and vertical asymptote. So for a log, let me go back. And then K, what is our K value? That would be the number on the outside of the parentheses in the back. Anybody? Besides Diana? Anybody know K? What's the number back here? Do you see a number? Yep, so 0. Good. So that's actually pretty easy for us because the only change that's going to happen is to x. Because you have to add the h to x, multiply y by a, and add k. But because a is 1 and k is 0, these numbers will not change. So the only thing we need to do is add 2 to all of our x values. So let's do that. And when you create your last table, and this is the table we're going to graph, again, these numbers don't change. Go ahead and add 2 to these 4 numbers. So that would give you 2.3, 3, 5, and 11. So this is the table we're going to graph. So let's go ahead and graph that. Now, before we graph it, though, let's answer these questions. Our domain, because h is 2, it's going to be x is greater than 2. We have a vertical asymptote at x equals 2. And every log function has a range of all real numbers. So I'm going to go ahead, because of that vertical asymptote, I'm going to draw in, and this graph is horrible. Like, it is so blurry to me. I don't know if yours is blurry, but my vertical asymptote is here, and I'll zoom back out in a second. Go ahead and draw in the dashed line at x equals 2. And then I'm only graphing that green table. And 11 doesn't fit, but I'm just going to pretend. I'm going to just put it right off the graph there. But regardless, you should kind of know the shape of your graph. So this is what your graph should look like. And I'll zoom back out so you all can see the entire everything. And that is your bell work. So we're getting ready to do the last leg of chapter 6. And chapter 6 is log. So and our chapter 6 test is next. It's actually, our test has been moved to Friday. To next Friday. It was supposed to be Thursday, but right now it's Friday. All right, so let's go to page, what page is this? 16. And we're only going to do a couple word problems, and then we will end for today. And you'll have time to start homework 5. Can I see your notepad real quick? I just want to see something. Okay, thank you. All right, so I'm going to read it twice. The first time I read it, I'm going to see what information looks important. I'm just going to kind of read it, and then the second time I'm going to circle important information. So it says DDT was an insecticide used by farmers. It decays slowly and is sometimes absorbed by plants and the animals that eat them. Data shows that 500 grams of DDT will decay to 450 in 5 years. Find the value of K in the formula. So they gave us a formula. Anytime they give us a formula, I think that's important to rewrite. So I'm going to just rewrite that. It says f of x, but it's actually, that's the same as y. And there's an error in this formula. There should be a t right here. Can you go ahead and add that t? There should be a t after k. That for some reason, I don't know why it's not there, but it should be there. Okay, so this formula, we're going to actually use this formula for number 1 and 2. So let's talk about this formula. In this formula, Y is your ending amount, A is your starting amount, and T is time. The K represents a constant that we're trying to find. So now that I am going to, and K is a constant that is only for DDT. Okay, so now let me read it a second time, and now I'm going to see if I can find some of these pieces of information. It says DDT was an insecticide used by farmers. It slowly decays and is sometimes absorbed by plants and the animals that eat them. Okay, so data shows that 500 grams will decay to 450 grams in 5 years. And it's asking us to find K. So K is what we're looking for. So I'm going to put my question mark here because that's what I don't know. So do you think that 500 is my start or my end? The start. So 500 is my start. In this example, 450 is the end. How many years did it say it takes for it to go from 500 to 450? 5. So now that we have all those pieces of information, we're ready to start substituting. And the only variable that we should have left is K. Hajar, you with us? She with us? Somebody get her. She needs to wake up. You need to sit up straight. Need to make sure you with us because we got tests next week. We can't be slipping on this test. We ain't got that many more left. I think we only got 2. All right, so let's substitute it in. So we have Y is 450. That equals 500. E to the negative, we don't know K, but we know that T is 5. Now, this looks weird. Now, it's nothing wrong with this, but we don't ever put a letter in front of a number. So I like to rewrite it and flip these two. So I'm going to rewrite it as 450 equals 500 e to the negative 5k. All right, so it's just 3 steps to solve it and we're done. The first thing we need to do is get rid of the 500. And this 500 is being multiplied. So we need to divide both sides by 500. So pick up your calculators. Take 450 divided by 500. Which gives us 0.9. E to the negative 5k. So who remembers from yesterday, what did I say? What log is the opposite of E? A common log or a natural log? Natural log. Let's put a natural log in on both sides. Has to be a LN, not a LOG, but a LN. And what that's going to do is cancel this out. So now I have natural log of 0.9 equals a negative 5k. So that negative 5k isn't an exponent anymore. So my last step would just be to divide by negative 5. So k equals the natural log of 0.9 divided by negative 5. Go ahead, type that in your calculator. Now, I had a couple students who were getting the wrong number first period. My recommendation is you use the fraction button. The button in the third row that says N over D. Use that button. So when you type it in your calculator, natural log of 0.9 divided by negative 5, you should get, oops, I typed it in wrong. Hold on. Negative 5. There we go. You should get 0.021. All right, raise your hand if you got that, or thumbs up. Any questions about how we work through that question? All right, we're going to do just 2 more. We're going to end with number 3 today. So just 3 questions. So 2 more and then we're done. So the second one has the same formula as the first. So let's look at that one. Now we're talking about radium, which is used for cancer treatment. It decomposes radioactively. It has a half-life of 1800. This is an important word here that we're going to talk about. Half-life, what does that mean? I don't know if you've studied this in biology. That that means that you end with half of the start. You snoring on my recording. And you sit up for me. You right here on my recording snoring. Okay, so that's what that means. So if it says half-life, it says you end with half of your start. So it says it takes 1800 years. That would be your t-value. We don't know k. That's what we're trying to find. So that's my question mark. And then it tells us that our initial value is 4,000. So is that my start or my end? What does initial mean? Does initial mean your starting amount or your ending amount? The starting amount. So that would be A. So to find Y, go ahead and take your start and divide it by 2. So your Y value is going to be 4,000 divided by 2. So go ahead, pick up your calculator and see what that would be. Anytime it says half-life, you take your start and cut it in half, or you take your start and divide it by 2, which should give you 2,000. So now we're ready to substitute it in. So we have 2,000 equals 4,000 e to the negative k 1800. But again, that looks weird. So I like to just flip it to 1800k, to negative 1800k. All right, go ahead and solve it. Same 3-step. Divide, put in the natural log, and divide again. So take about a minute and see if you can come up with your answer. It's going to be a really small number. .000 and then some numbers. So your first step is to get rid of the 4,000, divide it. And that gives you that 0.5, that's my half-life. Anytime you're doing a half-life, you will take the natural log of the half, because that's what half-life means. So you should have 0.5 equals e to the negative 1800k. Then we're putting in a natural log. That cancels out. And then your last step is to divide by negative 1800. So go ahead, pick up your calculator. Okay, it's going to be natural log of 0.5 divided by negative 1800. Divide that in your calculator and see what you get. And that's what you should get. It should be a really small number. So normally you will only give me 3 numbers after the decimal, but if the first 3 numbers are 0, then you have to keep going to give me as like actual numbers. So you can't just say it's 0.000. That's not, you just got to keep adding numbers until we get to actual digits. All right, last one for today, and then you'll have time to start homework. I don't know if this sounds familiar, but this was chapter 5. Before we do that, I'm going to remind you of this formula, and it's A equals PE to the RT. That's your continuously compounded formula. A was your end, P is the start, R is your rate, and T is time. Now, my recommendation is before we get into number 3, go to your homework 5. And I want you to write this information because you're going to use this information for numbers 2 and 6. 2 and 6 in the homework. So I'm going to give you a couple minutes to take out your homework and write that formula, and then we'll go through number 3 together. So you're going to use this compound formula for question 2 and for question 6. Anytime it says compound continuously, this is your compound continuously interest formula. That would be that. So go ahead and copy that down, and then we'll go through it together. Number 2 and 6 for homework 5. I might have said homework 6, but I meant to say homework 5. All right, so now that we have that copy down, let's go ahead and do number 3, and then we can end there. It says that you deposited $8,000, so that's important, into an account that pays 3.75% interest. That's important. How long will it take for the balance to double? That's important. So first of all, in this particular question, I am looking for T. T is my unknown. I started off with an $8,000 investment. Don't forget to take this number and divide it by 100 before you use it in the formula. So take 3.75 divided by 100. You always divide your interest rate. And that should give you 0.0375. Okay, but then it says that it didn't tell us the n, but it did tell us that it wants us to double it. When you double something, what are you multiplying it by? 2. So I want you to pick up your calculator to figure out the n. That's going to be 8,000 times 2. So 8,000 times 2 gives you 16,000. So now we have all of our pieces of information and we're ready. So we have 16,000 equals 8,000 E and then 0.0375. Ran out of space. Hold on. There we go. T. All right, so let's divide both sides by 8,000. The steps to solve it are the same steps we use in numbers 1 and 2. We're going to divide, put in a natural log, and then divide again. So 16,000 divided by 8,000 is 2. Now the opposite of E is ln. Put that in on both sides. That's going to cancel out the E. So we have the natural log of 2 equals 0.0375t. So your last step is to divide both sides by 0.0375. So pick up your calculator. T equals the natural log of 2 divided by 0.0375. So type that in your calculator and see what you get for T. And you should get about 18.5 years. Raise your hand if you got that. Anyone get that? Anybody need help typing it in? All right, so let's look at our homework real quick. First thing first, homework 5. Can you write that the due date, because we got a couple e-learning days in between, tomorrow is the SAT for juniors only, and then next Tuesday we have professional development, which is also e-learning. So because of that, we have homework 5 is not due until Wednesday. So what I want you to work on today is numbers 2, 4, 5, and 6. So we're going to skip over 1 and 3 and finish out this homework or this lesson on Friday. So use this time to work on your homework.